Today we start working with solving linear inequalities, and when we talk about an inequality, we're talking about things like x is greater than -7, things of that nature. And the first thing that you're going to be asked to do, we have to get used to interval notation. You're going to be asked to write an inequality for each interval. And I think they tell you to state whether it's bounded or unbounded too. So let's just look at this first one. -3, 5. The first thing that you have to know is that that is not an ordered pair. Okay? This is not an ordered pair. When I say an ordered pair, I mean an x, y. Okay? This is an interval. All right? And what it is saying is that we are going from negative, we are talking about all of the x's from -3 up to 5. All of the x's in between here. But you'll notice the -3 has a round parenthesis and the 5 has a square bracket. Well, that means that the -3, we don't include it. All right? But the 5, we do include it. So if I were to sketch a graph of that, that's what it would look like. We weren't asked to sketch a graph, but I'm using that to help explain what our inequality is going to look like. My inequality, since I have some values sandwiched in between, my x needs to be sandwiched in between -3 and 5. Okay? And obviously we're talking about all of the values that are less than 5 but greater than -3. But since we are including the 5, it needs to be less than or equal to right there. And there is our inequality that is the same thing as this interval notation. Okay? And that problem is done. Let's look at another one. -3 to infinity. -3 to infinity. Well, if we were to look at a graph of this one, it'd be real easy. Here's -3. We're not including -3, and we're going to forever. Infinity is forever to the right. So if I wanted to write an inequality for this one, we don't have a sandwich, do we? Okay, we're not sandwiched between two values. We're just saying, we're describing all of the x's that are greater than -3. Okay? And this one is unbounded. Remember I told you they might ask you if it's bounded or unbounded? This one's unbounded because it could go forever to the right. Let's go back to our first example. Is there a limit on this first example to how long this could be? There is, isn't there? So this one is bounded. Okay? Because that thing could never be longer than 8. Okay? There's no way. How about this one, 0 to 2? Why don't you see if you can write that inequality, and I'll pause the video. All right, let's see how you did. This one is a sandwich. I'm sandwiched between 0 and 2, and I'm including all of these values, so you should have had x less than or equal to 2, greater than or equal to 0. Okay, that should have been your inequality. Now, the next thing that we need to know how to do is to solve and sketch the solution. So they're going to give you an inequality, 5x minus 7 is greater than 3x plus 9, and they want you to solve it. Well, the good news is we just treat this like a regular old equation. We just have to remember if I multiply or divide by a negative, I flip the sign. So we just pretend that this thing right here is an equals. And we just go ahead and proceed like normal. Add 7. 5x is greater than 3x plus 16. Subtract 3x. 2x is greater than 16. Divide by 2. So x is greater than 8. I did not divide by a negative anywhere while I was solving it, so that is my answer. X is greater than 8. And if I wanted to sketch the solution, you don't have to spend forever on this. Here's 0. Here's 8. Open circle, since it's just greater than, sketch to the right. Okay? Now, obviously, these can look just as many different ways. They can look like a bunch of different types of things we've seen. Something like this. 1 minus 3x over 2 is greater than or equal to x minus 4. And there's one of our beloved fractions. And since we are solving something, even though it's greater than or equal to instead of an equal sign, we still want to treat this like we always do and get rid of fractions. Okay, remember I've been preaching about that. It saves you some mistakes. So I only have one denominator. What is it? 2. So we're going to multiply everything by 2. 2 times this, 2 times this, 2 times this, 2 times this. And I'm going to have 2 minus, those go away, which is what we wanted in the first place. 2 minus 3x is greater than or equal to 2x minus 8. And if I subtract 2 next, I have negative 3x is greater than or equal to 2x minus 10. Subtract 2x. Negative 5x is greater than or equal to negative 10. This time I am dividing by a negative. Since I am dividing by a negative, my inequality has to flip. So this is going to become less than or equal to. Don't forget that. And I will have x less than or equal to positive 2. How would I sketch that? Here's 2. Closed circle, sketch to the left. Okay? Sometimes you'll have the sandwich problems, like this. And if you have a sandwich problem, like this one, then you still do it the same way, but you're working with all 3 pieces simultaneously. So if I'm wanting to get x by itself, the first thing I would do is add 1. Well, that means I'm going to add 1 there, I'm going to add 1 there, and I'm going to add 1 there. So you do everything the same, you just do it in all 3 places at once. So I would have negative 2 now is less than or equal to 6x is less than 4. And the next step would be to divide by 6, right? So I'm not just going to divide by 6 there, I'm going to divide by 6 there and there. So those go away, and x is sandwiched in between negative 1/3 and positive 2/3. And if I wanted to sketch that solution, like I told you, don't spend forever on this. Here's 2/3. Here's negative 1/3. I'm sandwiched in between, so I'm coloring in here, and both the circles are filled in. Okay? All right, the next thing you're going to be asked to do is to solve and sketch, but now we're dealing with absolute value. Okay? So if you're given a problem like this, the absolute value of x is less than 8. Well, what we have to do anytime we have absolute value and we have to set up two things here. I know that x is going to be less than 8. Okay, that's one way. You always set it up the way it looks. Then you set it up and you flip the inequality and you multiply the other side by -1. Okay? And that does make sense if we think about it, because let's look at what my original problem is asking. It's wanting to know, when I take the absolute value of a number, and isn't absolute value always positive, right? Which x's will be less than 8 after I take the absolute value of them? Well, couldn't I have some negative numbers in there as well? Right? What's the absolute value of -7? 7. Is 7 less than 8? It sure is. So that's why we have to do this thing over here. Okay? So this one's already solved. Okay? It's already solved, but now we need to sketch my solution. So what is it saying? It's saying all of the x's that are less than 8 but greater than -8. So I've got an 8 over here. I've got a -8 here. So I want all of the x's that are bigger than -8 but less than +8. Open circles. All of those numbers in there would work. And if we think about it, that does make sense. Like I said, if I were to plug in -3, what's the absolute value of -3? 3. Is 3 less than 8? Sure is. Okay, so this does make sense. How about the absolute value of x is greater than or equal to 13? The reason I threw this problem up there is because the inequality is in a different direction. So I want you to see it kind of changes things a little bit with my final answer. We're still going to set it up both ways, like I told you. X is greater than or equal to 13, and x is less than or equal to -13. It's already solved, but your graph is going to look a little bit different. This one, we're going to the outside. Okay, I still have these two numbers, but my answers are greater than 13, greater than or equal to, color it in, sketch, and less than or equal to -13. So it's a little bit different looking graph, which is why I did it. Yes? We're not worried about that on this problem. Technically, if that question came up on this problem, it would be unbounded, because it's going forever towards infinity and negative infinity. Now, moving right along, the absolute value of x minus 7 is less than 3. Well, like I told you, we're going to set up two inequalities. We're going to set it up the way it is. X minus 7 is less than 3. And then we're going to set it up by flipping the inequality and making it greater than -3. Okay. So then we need to solve both. All right, so add 7, x is less than 10, add 7, x is greater than 4. Okay, so if I sketch this one, looks like I'm stuck between 4 and 10. Yes, I am. Because I'm less than, oops, that should have been open. Sorry about that. That should be an open circle. Less than 10, greater than 4. Okay? Sometimes you just flat out need to pay attention. When you see these problems. Now let's think about this for a minute. That's saying the absolute value of something is going to be less than negative 8. Is that possible? Look at what this is saying. I've got an absolute value over here, and we're saying it's less than negative 8. Somebody pick a number less than negative 8. Negative 9. Can I take the absolute value of anything and get negative 9? No. No solution on this one. Okay. All right, let's get to where we're going to use a graphing calculator. Use the TI-84, I think they call it a graphing utility, to solve. And let's say that they give you this. The absolute value of x minus 5 is less than 2. Okay? Well, there's actually a couple ways that you could do this. But let's kind of figure out what this is saying. It's saying, where is this thing less than 2? Okay? So I'm going to show you a trick for this. Let's go to the graphing calculator. First thing you have to know is how to get to the absolute value symbol in the graphing calculator. It is under the Math menu. So if I go to Math, and you need to scroll over to the right to Number, it's the very first one. Okay, so there's absolute value. So you hit Enter. And my absolute value was of x minus 5, so I put my x minus 5. All right. And now we're ready to take a look at the graph. So I'll hit Zoom Standard. Okay. So there's the graph of x minus 5, the absolute value of x minus 5. Get this into a place where I can write on it. So there's my graph, but what is this question asking? It's asking, where is it less than 2? Well, we're talking about, here's 1, here's 2. What we're going to do is we're going to put in that horizontal line y equals 2 so we can figure this out. So let's go back to the graphing calculator and let's add in a line. We're going to add in y equals 2 because we want to know where is this thing less than 2. So if I look at my graph now, okay, I can see there's a little triangle there, right? Okay, so what we're going to do is we're going to calculate the intersection point. Now watch carefully. You press second, trace, and do you see number 5 for intersect? Press number 5. And it asks you for the first curve. All you got to do is just move your cursor down to the intersection that we're looking at. Hit Enter. Then it asks for the second curve, and you'll notice it goes to the y2 formula, and you just hit Enter again. It asks you if you want them to guess, and we say yes. And there's your intersection point. Okay? It's 3. Okay? And then we do it again for the other one, second trace, 5. And I'm going to move this thing over to where I want it to be, to right there. And I'm going to hit enter, and I'm going to hit enter, and I'm going to hit enter. And it's 7. So those two intersection points were 3 and 7. So, what's my answer? Well, we said we wanted to know where is less than 2. Well, we found out that this was 3 and this was 7. So when is it less than 2? When x is between 7 and 3. Okay? For all those x's between 7 and 3, this absolute value function is less than 2. Okay? And you're going to have a couple other problems using the graphing calculator, and you do them in a similar way. What if they give you y equals 3x minus 4 and say, where is y less than or equal to 3? And I'm not going to go to the graphing calculator, I'm just going to kind of talk your way through it. You're going to sketch this, put that into the graphing calculator, into your y1. It's going to be a linear, like that. And they want to know, where is it, okay, where is y less than or equal to 3? We're going to do the same thing. We're going to graph the horizontal line, y equals 3. And we're going to calculate this intersection point, and it would be all of the x's to the left there. And we will stop there for today.